Hi, the next topic is apply function. The apply function calculates statistics such as mean and standard deviation or any function such as skewness, kurtosis for each row or each column. And this is a kind of general function. So for example, the mean function is used only when we want to calculate mean. But applied function is used in combination with another function, and we apply that function repeatedly for all, all of the each of all columns or each of all rows. Okay, so we start with an example. So suppose we have the three vectors A, B, C. Vector A is defined by the vector of 7, 10, 8, 9, and B, it's defined by 7, 8, 9, 10, and C defined by 12, 8, 9, 7. And remember that this semicolon works as a separation symbol for lines. So semicolon, at semicolon, are recognized that the line has been changed. So we defined A in this portion, and after that we change the line and we define the vector B, then vector C. And R is case sensitive, so you can define the capital C, the object capital C. The lowercase c is reserved to declare a vector, but capital C can be defined. And ABC we defined, and we combine these. So we construct data frame consisting of A, B, and C. Or you can simply declare a matrix because all things are numbers. So this is this data frame. So if you wanna calculate the summation for each row, so 7 plus 7 plus 11, 12, and 10 plus 8 plus 8, and 8 plus 9 plus 9, and 9 plus 10 plus 7, you can do it at once by using apply function. So apply D, this is the object, then 1. 1 means the first index. So the rows are the first index, so the by row. Then take summation. Then apply D1 sum returns 26, 26, 26, 26. Actually, you can see 7 plus 7 plus 12 is 26. Right? And 10 plus 8 plus 8, 26. Actually, everything is 26. And if you want to calculate the summation for each column, then you can specify 2. 2 is the second index, so that is column. So each column, for each column, we can calculate summation. But this is not interesting. So this time, we can do mean. Okay? Then we get the mean of A, mean of B, and mean of C. For example, you can see C, 12 plus 8 plus 9 plus 7 is 36. So divided by 4 for observations, so that is 9.0. So apply function works in this way. And next we study some variations of apply function, L apply, S apply, and also T apply function. So sometimes the object is not given as a data frame, but just in a general list. Okay, so L apply function and L apply function and S apply functions can be used for that case. For example, suppose E consists of just one observation, 2.5, but F consists of 3 observations, so 0.7 and 0.8 and 0.9. Oh, and actually you can omit 0.9 is recognized as 0.9. And G is defined by 0.1, 0.2, 0.3, 0.4, 0.5. This is another another typical data. Something was missing. Oh, I think I missed C here. Okay, so So this is a typical data. For example, the first data set includes 1 observation, but the second one, 3 observations, and the third one, 5 observations. But we want to calculate the mean for each vector. That is very a common situation. So in that case, we can use just list. We cannot use data frame because data frame should consist of the vectors with the same length. So we have to use list. So we declare a list consisting of E and F and G. So L1 is this object. First object is E, second F, third G. Then you can apply sapply function. Then, okay, so this list is named as L1. So L1, then mean. Then you can get the mean of E, that is obviously 2.5 since we have 1 observation. Mean of F is 0.8, mean of G is 0.3, you can see. Next, lapply function. Lapply function is similar to sapply function, but the output is also a list. Okay, so L1 consists of 3 objects. So L1 is a list, but the sapply function output is a vector. Okay, so 3 objects to 1 vector. lapply function, it keeps the list structure. Okay, so just we try. So lapply, L1 mean, then again we get 2.5 and 0.8 and 0.3. But actually the output is a list, okay, list consisting of 3 objects. The first one is E, second one is F, and the third one is G. So it has the same structure as L1. And those values are 2.5, 0.8, and 0.3. So this is sometimes convenient because if we keep the same structures, the sum code works simpler than this sapply function. And lastly, the tapply function. This is slightly different. So tapply function, we need 2 vectors. So 1 vector to define category, and the second vector is numeric vector to be summarized. So for example, the first one, the gender vector, MF, MFM. Oh, by the way, you have to be careful that when you define a very simple object, then F and T, capital F and capital T are not recommended to use because the T is recognized as true, the logical value of true, and F is recognized as the false. So actually that we defined vector F, but this is a possible source of errors. So we should avoid this. But if we put it in a quotation symbols, then that's totally fine. So I'll just recognize this as a sequence of characters. So that's totally fine. Oh, sorry. This is a vector, so we have to declare a vector. So that we have to put the lowercase c parentheses. And gender we defined. And blood pressure of these 5 people, suppose those are 120, 111, and 132, and 94, and 85. Then we define the data frame as gender vector and BP vector. So this. And we want to calculate the blood pressure, average blood pressure by gender. That is also a common task in statistics. And in that case, we can use tapply function. So the first vector is the vector to be summarized, so blood pressure. And the second object is the key, so gender. We want to summarize blood pressure by gender. So Then third element is the function. So we want to calculate the sample mean, so mean. Then we get this, the female 102.5, male 112.3. And if we put standard deviation, you can get the 12 and the 24.4. So t-apply function works this way. See you then.